You know, the most powerful lessons, they aren't always buried in some dense research paper. Nope, sometimes they're just hidden, right there on a single page of a textbook. And today, we're going to unpack the genius that was hiding on one of those pages. It all kicks off with a really simple, everyday task.
Okay, so here's a scene I bet we've all seen a million times. Maybe you've even been the one doing it. It's just pure physical effort, right? Someone moving a heavy load, all muscle and strain. And your first thought is probably just, wow, that's hard work. But what if there's way more going on here than meets the eye?
So let's just hit pause for a second. If we look a little closer, beyond all the sweat and the straining, what's really happening here, mechanically speaking? I mean, we're talking about force and leverage and balance. It's a whole system of physics in action right in front of us.
All right, so let's do exactly that. We're going to take this from just a chore and turn it into a concept. We're going to break down this ordinary wheelbarrow and look at it as a system of movement, just to see how it really works.
So it really all comes down to how these different parts work together, right? You're actually applying two forces at once, a forward push and an upward lift. That wheel, that's your pivot point, your fulcrum, and it's what makes the load so much easier to handle. Meanwhile, your arms and legs are the support structure, keeping everything stable and moving forward. The whole goal, the whole reason it works, is efficiency.
But then, just when you think you've got it figured out, the source material throws this just fascinating curveball. Right after explaining this totally solo task, it asks this question: can you imitate the movement in pairs? I mean, in pairs? How on earth do you imitate pushing a wheelbarrow with a partner? What does that even look like?
And this, right here, is where the genius of it all just clicks into place. This is the exact moment that a simple lesson in basic physics takes this incredible creative leap and becomes a lesson about play and trust and cooperation. And this slide just illustrates that leap perfectly. On the left, you've got the original inspiration, right? A solitary, purely functional task. But on the right, you have its playful reinterpretation. It's like the source is asking us to draw a line between the two, to see that direct connection and understand how one can literally become the other. And that, of course, brings us to what's called the human wheelbarrow. So what is it? Well, it's a cooperative exercise that mimics the very same mechanics we were just talking about, but, and this is the key, it replaces that simple machine with something way more complex and dynamic, another person.
And the source doesn't just throw this out there as some vague idea. Oh no, it gives us a really clear set of instructions. It basically turns this whole concept into an actual game with its own set of rules.
And the instructions themselves are just so beautifully simple. Okay, so first you find a partner. One of you, the wheelbarrow, starts in a push-up position. Then the other person, the pusher, comes along, carefully grabs their partner's legs and lifts them up. The wheelbarrow supports all their weight on their hands, and then you try to walk forward together. Simple as that.
But here's what's really important. Within those simple steps, the source puts a ton of emphasis on two specific phrases: walk carefully and take turns. Just think about that for a second. Built right into the rules of this game are these massive lessons about safety, about responsibility, and about fairness. It's not just about doing it, it's about doing it the right way.
Okay, so now we know how to do it. But why is this imitation so incredibly clever? Well, to really get that, we need to actually compare the physics of the real thing to the human version.
Okay, this is where it gets super interesting. With a real wheelbarrow, the load, dirt, rocks, whatever, it's just dead weight. It doesn't do anything. But in the human version, the load is an active, dynamic partner who has to constantly adjust and balance. And the pivot point? It's not a simple wheel anymore. It's the super complex system of your partner's shoulders and their core. And maybe most surprisingly, the force that moves you forward shifts almost completely from the pusher's legs to the wheelbarrow's arms.
And once you understand those differences, you start to see the real takeaway here. This whole thing, it's so much more than just a clever game or a fun gym class exercise. It's really a masterclass in learning with your body and learning with other people.
I mean, just think about everything that's being taught here, all at the same time. Sure, there's upper body strength, obviously, but you're also forced to trust your partner completely. You literally can't move without communicating. It is teamwork. And then, because you switch roles, you build empathy. You get to physically feel what the challenge is like from both sides. This is the absolute definition of learning by doing.
So when you boil it all down, the genius is actually pretty simple. It takes a task that's all about individual effort, and it transforms it into a shared challenge that is completely impossible to solve by yourself.
Just one activity, one simple idea from one single page of a book, and is teaching physics, biology, and social dynamics all at the exact same time. Incredible!
You know, it really makes you think of that famous quote from Albert Einstein, right? The highest form of research is the observation of a child at play. This exercise is a perfect example of what he was talking about. It's proof that sometimes the most profound learning, well, it just looks like kids having fun.
And that kind of leaves us with one last thing to think about. I want you to forget about all the lectures and the textbooks for just a minute and think about your own life. What's the most powerful lesson that you ever learned just by playing a game?